Okay, hello everybody. This is Mr. Eugene. So I'm going to go through this paper over here. So let's look at it now. So this is the section B of ZhongHua Prelim paper for 2018. So let's look at the figure here. So this figure 11.1, it shows a circuit breaker that could be used in household circuits. So this is a circuit breaker. So circuit breaker main idea is to disconnect, okay, the circuit. Disconnect the high voltage terminal from the circuit from the appliance / circuits. So this is the function of a circuit breaker. So in this question it says describe how the circuit breaker switches the circuit off when electrical fault causes the current through the coil to become too large. Now before we go into the question itself, we need to understand how this circuit works. So the current is flowing in this way. It will flow through the iron core, and because there's a coil over the iron core, this guy here becomes a temporary magnet. Okay, temporary. Now, because this is a temporary magnet, it will attract, okay, the iron armature. Okay, so just take note of this first. We'll go into further details over here. Anyway, back to the flow of the current. So the current flows around the coil of wire. It goes to the pivot over here. Because this an iron armature is a metal, so it will conduct electricity towards the contact point and out over here. So this is the natural flow of the current. Now, let's try to tackle this part over here. So when the magnet is working, okay, because when the current flows, it becomes a temporary magnet, it will attract this iron armature. So this attraction actually causes a downward force over here, and because there's a pivot, we know that we need to think in terms of moment. So when there's a downward force over here, it actually generates what we call a anti-clockwise moment. Okay, so the whole iron armature is supposed to rotate anti-clockwise. However, it is not rotating. Why? Because the spring over here is also exerting a downward force. A downward force over here, the pivot over here, this actually gives a clockwise moment. So the whole iron armature remains in its current position because the anti-clockwise moment generated by this attraction is not able to overcome the clockwise moment generated by the spring. Okay, so this is the current situation when the whole thing is working normally. The current will just flow, goes to the pivot, goes to the contact point, and flows out. So it will just flow through the whole circuit over here. Now, but when the current becomes too large, so I'm going to use the green color now to show. So when the current becomes too large, so same thing, the current will flow this way. It will flow through the iron core. Now, but because the current is larger now, this will cause the attraction to be stronger. And if the attraction is stronger now, my clockwise moment generated here will be stronger than my anti-clockwise moment generated here will be stronger than the clockwise moment generated here. As such, my pivot will actually, my iron armature will actually rotate anti-clockwise. So you will realize that if this is the contact point, the whole thing will suddenly look like this. Okay? And it will be touching the iron core. And the spring is actually like this. And the spring is actually like this. So this is how it will look when the current becomes too large. So to tackle this question, you need to first be able to imagine what really happens. So now I've described what happens normally. I've also described what happens when the current becomes too large. So this is the kind of image that I need you to know. And now with these two ideas that you have here, it's time to run through the questions. Okay, run through the answer to the question. So first point, when the current through the coil becomes too large, it causes the induced magnetism of the iron core to increase in strength. So it's the increased attraction here. Okay? This actually causes the left side of the iron armature to be attracted stronger, causing it to rotate anti-clockwise about its pivot due to a greater anti-clockwise moment. This is the second point we want to see. Because of the great anti-clockwise moment, it will rotate. Okay, so after it has rotated anti-clockwise, what actually happens here? Okay, it will then detach itself from the spring and the contact point will not be touching, resulting in the circuit being switched off. Okay, so this whole part here actually is talking about the contact point being open and hence the circuit switches off. So there's actually three parts to the answer. First, magnetism, induced magnetism increase in strength. Second part, we talk about the moments. Okay, talking about because of the stronger attraction, that it will generate a greater anti-clockwise moment. Okay, this will actually overcome the clockwise moment by the spring. And lastly, because of this attraction, it causes the contact point over here to be open. And because it is open, the circuit cuts off. So these are the 3 points that you need to have in order to get the full marks for part A. Part B. Okay, explain why the circuit breaker is connected to the live wire instead of neutral wire. So we need to explain why is it connected to the live instead of the neutral. So first thing, by connecting to the live wire, it will disconnect the high voltage terminal. Okay, I want to see this point of the disconnecting the high voltage terminal. Okay, because the live wire is actually the high voltage wire. So if I connect the fuse to the live wire, okay, it will actually disconnect the high voltage terminal from the household circuits. Quite a number of you talk about the neutral wire and stuff like this. So actually the key idea here is why the live. Okay, the other part, of course, you can talk about neutral being 0 volts, but you realize you're still not answering why the fuse to the live wire. What's so important about live wire? Because the live wire is the high voltage wire. If I'm able to disconnect the live wire, I'm actually disconnecting the high voltage terminal from the household circuit. Okay, so this is the one point that I want to see over here. Okay, let's go next one. Figure 11.2 shows the coil of wire and the iron core inside the circuit breaker. Okay, so this thing is 3 marks. So exactly where are the 3 marks? So 1 mark goes to the pole, north pole over here, south pole over here. The few lines, just think of it as is like a magnet. There's north and south. Ignore the coil of wire once you have used it to determine the north and the south. Okay, then you can draw your respective magnetic field pattern. Okay, now lastly, take note, north, okay, the magnetic field lines are pointing away or out of it. South, the magnetic field lines are pointing in. Now, some of you might be having this question, how do I know that this is north, this is south? Actually, what you need to do is you need to use the right hand grip rule. Okay, use the right hand grip rule. Follow the coil of wires, and you realize this is where the thumb is pointing. So the point where the thumb is pointing, that's where the north pole is. And hence the other side is the south pole. So 1 mark for the pole, 1 mark for the pattern in terms of the field lines, and 1 mark in terms of the direction. So 3 marks. This is quite an easy mark if you are able to understand what is required of you. Okay. Part D. In some circuits, circuit breaker is used to do the same job as a fuse. One advantage of using circuit breaker instead of fuse is that the key idea, it can be resetted, it can be reused. Okay. Many of you talk about the fuse only can be used once, but actually realize the main point of talking about this is actually what's so good about the circuit breaker. Okay, so this is the 1 mark that we are looking out for. And lastly, part E, explain why the metal core inside the coil of wire should not be made of steel. First thing, you need to highlight that the steel is made out of hard magnetic material. Okay, made out of hard magnetic material. So as such, it will continue to attract the iron armature even after the current stops flowing because it is a hard magnetic material. Okay, or the other way is, okay, there's actually one more possible answer, is that it will take a longer time for the attraction to be strong enough to break, to cause the circuit to be open, to cause the circuit. Okay, So one thing is really to talk about steel being a hard magnetic material. So some of you may say, "Cher, what if I write steel is difficult to magnetize and demagnetize?" So that point that you've written is actually just explaining that it's hard magnetic material. The second part really is to explain what's the deal about it being a hard magnetic material. So this is point E, so take note of it. Okay, so that's for the first question. The next one, question 12. Okay, so we're going to go on next part. So figure 12.1 shows part of a lighting circuit connected to the main supplies of 240 volts. So 240 volts over here. Now, the place where the fuse is attached. So if you look at it, this is a household circuit. The place where the fuse is attached tells me that this guy here is the live wire. This guy here, hence, must be the neutral wire. Okay? In a normal circuit, actually, a live and a neutral wire is sufficient. So live wire here. So along this whole line, this is 240 volts. This is 240 volts. This is 240 volts. This guy here, because neutral wire, 0 volts, 0 volts, 0 volts. What does it mean? It means that the potential difference across all the lamps, this one here is 240 volts, 240, 240. Okay, so this is what I can get from the current diagram here. Okay, now let's go into the question. A fuse of 10 ampere is connected to wire X. Okay. Explain the purpose of a fuse in the circuit and name wire X. Name wire X. Name already. So we say wire X is a live wire. 1 mark over here. Next one. Okay, we need to explain the purpose of a fuse. So the purpose of a fuse is that it will disconnect the high voltage terminal from the lighting circuit when the current is too high. Okay, so what I did was I give 1 mark here. First is to describe that what happens to the fuse. So it gets heated up and melt. That's the first point we want to see. Okay, if you want to add in here the thin wire in it will get heated up and melt, I think that's a more complete answer. So that's the 1 mark that we want to see. Second thing is it disconnects the high voltage terminal from the lighting circuit, causing the circuit to be open. So this is the second mark over here. And the last one is actually this idea of a current being above. Okay. So that's the 3 parts over here. So current being above actually says, what does when does the fuse activate? Okay, when does the fuse activate? So fuse activate and then causing it to melt. That's 1. Second part, disconnect the high voltage terminal from the lighting circuit. That's 2. So how does it disconnect? It's actually causing the circuit to be open. So 1, 2, 3. And the last part, the last 1 mark, because it's 4 marks, is actually saying that the live wire is wire X. So 4 points over here. Okay, so I repeat again for this one. By saying that when the current is too high, it will cause the wire in it to be heated and melt. 1 mark. Another mark goes to disconnecting the high voltage terminal from the lighting circuit. That's 1 mark. Okay. And the last one goes to causing the circuit to be open. Because how do you disconnect? It's actually to open the circuit. Okay, cause the circuit to be open. The last one, wire X is a live wire. So that's the 4 points to cover for this elaboration. Part B, explain whether a fuse can still serve its function if it's connected to wire Y instead. So when it's connected to wire Y, okay, will it be able to cause the circuit to be open? Actually, the answer is yes. It will be able to cause the circuit to be open. However, it will not be able to disconnect the high voltage terminal from the circuit. So in a sense, it fulfills half the purpose, which is causing the circuit to be open. But it does not serve its purpose over here. This part is the one that's missing. So for neutral wire, if you attach a fuse there, it can cause the circuit to be open. However, it will not be able to disconnect the high voltage terminal from the circuit. And hence for part B, whether can it serve its function, it will not be able to serve its function. Because neutral wire is 0, when it melts, it will not disconnect the high voltage terminal from the circuit. Okay, so that's for part B. Part C, 3 lamps are shown, each rated 240 volts, 60 watts. So for one of the lamps 240 volts, 60 watts, they want the current. So the current in each lamp, because this is the rating, I use the formula P equals to IV. Power is 60, current is what I want to find, voltage is 240. So if you have to do your substitution and math, what you're going to get, you get 0.25 ampere. Next, determine the maximum number of identical lamps that can be connected parallel. So if it is parallel, okay, do take note, each lamp will actually draw 0.25 ampere. So hence the maximum number of lamps is 10 ampere divided by 0.25 ampere. Actually what you get is 40 lamps. But at 40 lamps, you actually draw 10 ampere. 10 ampere, that's the current. Your fuse rating is actually also equals to 10 ampere. So when the current is 10 ampere and the fuse rating is 10 ampere, what does it mean? It means that the circuit, once it hits 40 lamps, the fuse will immediately blow. As such, I cannot leave my answer as 40 lamps, because at 40 lamps, it will not function properly. So I need to cut down on one lamp, and hence the maximum number of lamps is 39 lamps. Okay, so that's for question 12. Last one, question 13. Figure 13.1 shows an engine pulling a oil tanker. So this is the engine over here. This is the oil tanker. Now, table 13.1 shows some information about the engine and the oil tanker. So the mass of an empty tank. So the tank empty, 3000 kg. Maximum volume of oil that the tanker can carry, 25 meter cube. Density of oil, 740 kg per meter cube. Contact area between the tanker's wheel and the track, okay, 0.86. So contact point, contact point, contact point, contact point. This whole thing here is 0.86 meter square. Now, define mass. Mass is the amount of matter in an object. This one is actually just purely from the textbook. So memorize the definition. Now, B part 1 says calculate the mass of oil in the tanker at a full capacity. I only want the mass of the oil. Okay. As such, to find the mass of the oil, I'll take the density of the oil multiplied by the volume that the tanker can carry, which is 25, well, I guess 18500 kg. So that's the mass of the oil. Now, do take note, part 2, it says the weight of the tanker when it is full. So the weight of the tanker actually consists of the weight of the tank plus the weight of the oil. So in order to find the weight, I need to take the mass of the tank plus the oil. So 3000 is the mass of the empty tank. 18,500 is the mass of the oil. So which is 18,500. So I'm going to get, when I add both up, is 21,500 kg. So once I've done this, I know the mass of the oil plus the tank. I will just use W equals to mg, where weight equals to mass times gravitational field strength. So it's just a matter of 10. So I'm going to get 215,000 Newton. So that is the weight of the tanker. The weight of the tanker. Now last, in part 3 here, or part B, last part, part 3, the pressure exerted on the track by the tanker, find the pressure exerted by the track, on the track by the tanker when the tanker is full. Give your answer in kilopascal. So pressure, I know the formula is P equals to F over A. The force here is actually the weight of the tanker plus the oil. So it's 215,000, that's the force here. The area is the contact area, which is 0.86. So when you do your math over here, you're going to get 250,000 Pascal. But however, they want it in kilopascal. So what I need to do is from here to here divided by 1,000. So I get 250 kilopascal. So that's the answer over here. Okay, so that's the answer for part 3. And lastly, part C here, explanation question. In an unfortunate event, there was emergency brake. The oil tanker was not tightly secured and was dislodged, causing an oil spill and dangers of explosion. Now, the question says, why is it difficult for the oil tanker to come to an immediate, the word is immediate stop, despite the emergency braking? So, what we are looking at here is, why is it difficult to stop? So this is actually trying to use inertia, bring in the concept of inertia, which is the reluctance of an object to change. Okay, to change its state of motion. Okay, so due to the high or huge mass of the tanker, okay, huge mass of the tanker, it has high inertia. Now, some of you use the term heavy. Do take note, we are looking out for the key term here. It is actually mass. So high mass equals high inertia. This is the first point we are looking at. High mass, high inertia. Okay, second point is that what exactly is inertia? So it's the reluctance of an object to change its state of motion, which means to make it come to a stop. So that's the second mark. As such, this is how you're going to get 2 marks, relating mass to inertia. Second thing, explaining what inertia actually is. Okay, so this is the end for this going through of this paper. Should you have any question, please feel free to ask your teacher. Okay, thank you very much. That's the end.